after the area and the perimeter section, the next section you met is the chords of a circle. You had this section called chords of a circle. So that is the second part. Okay. So chords of a circle. So what is a chord? What is a chord? So you know, this is the circumference. A chord means the line joining two.
And from 2 points from circumference of the circle.
Yes, the line drawn from 2 points of a circle is called a chord. Then you have a chord going through the center. What is called a chord going through the center? Yes, the chord passing through the center of the circle is called the diameter. Okay. If this is the center of the circle, the first theorem is if you draw a perpendicular to the chord, you are going to draw a perpendicular to the chord. So then, what can you tell about if the line from center O, the perpendicular drawn from center point O to AB is perpendicular? Yes. Yes, so it is perpendicular. So if it is perpendicular, the distance AC is going to be equal to BC. So it is going to bisect the line, the chord AB. The perpendicular drawn from point A will bisect the chord AB. So this distance is going to be equal to this distance, right? So how can we prove that? Yes. Or else you can use the congruency, right? So if you construct two lines like this, you know this length is equal to this length, right? So that length is equal to this length, then this angle is also going to be equal to this angle. This length is common and here is 90 degrees. So you can say these two triangles, I'm not going to prove it. So proof in detail is in your book. So I'm not going to prove in details. So I'm going to just summarize. So you can prove that these two triangles are congruent. So this AOC triangle and COB triangles are congruent. So if it is congruent, the corresponding sides are equal. So this side is going to be equal to this side. So similarly, the other way. So if there's a chord AB, if there is a chord AB, you have the center. If you draw a line to the midpoint of this chord, right? So if you draw a line to the midpoint of this chord, the theorem says this is going to be perpendicular to AB. So if this is the midpoint, it is going to be perpendicular. Or if this is perpendicular, it is going to be the midpoint. So anyways, both way around you can use. If it is perpendicular, the lengths are going to be equal. AC is going to be equal to CB. If the lengths are equal, if AC equal to CB, then this line is going to be perpendicular to the chord. The theorem is the straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord.